Yeah. So if you are able to see the screen, you can also just say yes or just send an emoji reaction so that I know that you are okay on the screen side. Okay. No, no, nothing has been sent. I don't know if all of you are able to see the screen. You can type yes. Okay. I've seen Pashamai confirm, so I think we are fine. Yeah. So you had a look at R or maybe just installed R, and it should be looking like what we have on the screen, right? If yours is different from this one, there can be an instance where it's like this, so you can't see one of the quadrants. So so maybe you can hide this so that there's console here, and let me just pull it again. Yeah, so that it appears in more of a four-sided. There's this section here, and there's this console section here. There's the environment section we have here, and also there's now this files section that you can see here. So you can even resize it so that it remains like they're on the same level. There's a console, there's a file section, there's an environment section. There's also where you are going to be writing your codes. You can write the scripts here, you can even write the scripts here. So both of them can be used for writing. Are you able to see that it's similar this way? Yes. Or if you're having anyone different from this. This is RStudio. There are those people who installed RGUI, the graphical user interface. Let me see if I have the RGUI. No, I don't have it. I just have RStudio. RStudio is what I installed, the IDE that is used for writing codes in R. Yeah, so I hope also you have loaded the data set, not the data set, but the code that I sent. This is like an introductory class, and we are going to go through these codes up to 124. Yeah. So when you open your R, this is what you'll be seeing. And you can see there's a file section here. If you want to open a new file, you'll click there. You can even write a project, not really a project, but develop a folder, a project folder where you will be storing all the files that you're working with as far as that specific project is concerned. It can be a data analytics project that you are doing, so you can just maybe name it give it a name as a project, or you can just be having independent files, right? Independent files there. So under the file, you can control Shift N for you to open a new file. We also have R notebooks, we have R Markdown. You can even see there's this Shiny Web app. So this is more of like for development of web applications and such like stuff. There are even like Python scripts, the shells and the SQL scripts and such like stuff, which you can also have in R. You can even also see like we have even C++ files. For you to open a file, Control plus O, or just click on this open a file so that you can open a file. You can even open a project. You can open a project in a new session. You can see the recent projects that you've been working on. Maybe mine doesn't have because I've not written a project. I have independent files. You can do importing datasets, right? From Excel, from SPSS, from SAS, from Stata. Yeah, so we'll see even the readr package. We'll talk about it. You can even save all those things, save all Alt plus Control S, or just save as Control plus S. So when you're saving it, of course, for the first time, you'll be using save as. So those, I think, are basics that you will be using, or maybe that you know. You can close by clicking Control plus W. So, or just close by maybe save your file and just click on this so that it closes everything that you're working on. But if you want to go the shortcut way, Control plus W, and you will have closed your console. Edit section, you can see undo. Of course, these are shortcuts for editing anything that you're working on. So Control plus Z, maybe you've made a mistake, you want to go a step backward. You want to go a step forward, redo, right? You want to cut something, you want to copy, you want to paste. These are shortcuts that we have been using in even in Excel. And also another thing is the indentation, right? And I think the indentation you went through even in Python, and you can use the Control plus Shift and V, right? There's also a way that James was selecting even everything in Python, right? You can even be using Control plus A. You can go through this, even replace and find here. You can go through all these shortcuts so that you see what it means for you as far as working with in R is concerned. Yeah, so you can go through these tools and just see what it does for you. You can even go under tools and maybe go to something like global options, and you can even change appearance of how your codes are going to be appearing, right? Maybe my default is TextMate. You can play around with these ones to see how they are going to appear, right? You can change their colors and such like stuff. It's blue, twilight. There are those who like that one, or Crimson Editor. It can appear that way. You can, if you like chaos, you can also have chaos there. So this is how it will be appearing. If you enjoy ambience, that is something that you'll be interested in. Yeah, so depending on, ladies are always good with the colors. Maybe you may want to use them. For men, I believe maybe whatever works. So when you selected one, you just click on and apply, right? And then that will be okay. Uh, is anybody having an issue with that? So you can see how mine has changed, right? But maybe I want it to go back to where I was. I don't want it to appear this way. I'll just click back that tools and go back to global options and go to appearance, and it was TextMate, the default one. Then I'll click just OK to get it back, right? So you can even also play around with that just to customize the appearance of your of your console. So here you'll be writing codes in this place, right? You'll be writing codes. So for example, let me say I want to write maybe what is your name, or maybe let me just say name, and my name maybe is so we have this variable called name, and this is, maybe I've written it very fast and some of you haven't captured how to write that. So name, and then there is the less than. Is it less than? So you press on shift and then the less than, and then there's that hyphen next to zero. So you can just click the hyphen next to zero, and then you have maybe your name as Boniface, or your name as Eric, or your name as GLM writer, right? And you can save it. So when I object name not found. So name object name not found. Let me use a different. Let's use something like maybe var. Let me see what the issue is. Okay, why? So I used name. Name is not accepted because name is an inbuilt function. Is an inbuilt function in R. That's why it was having an issue. You'll see that in rules for writing names here. So for example, reserved words cannot be used as variables. For example, true, false, null. And if you try to write even this code here, null, and try to run it, you'll see that is invalid. It's invalid or something. Okay. But I believe name should be working. Let me just confirm again. Name. Okay, yeah, name should be working. Okay. So that's it. Let's now start what you are doing. Okay, so introduction, of course, R is used for data analysis and then visualization, machine learning, the application development. And one of the advantages is that it is open source. What does it mean when you say something is an open source? Eric, what does it mean to say that something is an open source? Eric, if you're speaking, your microphone is on mute. Nathan Ngetich, you're asking how do I exit the tools window? It's either you click OK so that the changes that you have put be applied, and then if you are here, if you are in the tools section, you just click on yeah, I believe maybe where you are is you are here, and maybe in appearance and such like stuff, Dracula, and maybe you've changed it to Solarize. You can just click on OK or click on Apply, and then so let me click on Apply. Okay. Yeah. So when you click on OK, of course the tools window just goes away. You can apply and then click on OK so that it goes away. Nathan Ngetich, I hope you are answered. Eric, we asked a question that what does it mean to say that something is an open source? Or Eric is not able
License.
to. Sorry?
License.
Yeah. For example, if you try to download SPSS, you'll find that it is licensed and therefore you have to pay. You're required to pay for it. But for Python, you see, you are just downloading without any. For R, I mean, you are downloading without any issue, right? And something that I maybe failed to tell you before going to that, of course, R also has so many numerous packages that we are going to see again. But when you write a code here, it is going to be executed in the console. And even in the console also, you can write your codes in the console instead of these other ones. Let me just, yeah, I can have it this way and be writing my code like, let me say country. Let me say country and write it as our country is Kenya, or I am from Sao Tome, right? And just remember that this is a string, and so it has to be Sao Tome. So it's still executing. So that if I want to run, maybe tell it to get for me country, then it will write for me it's Sao Tome, right? And whenever you write a variable, it's going to be shown in the environment. You can even see that the environment here is, we are having a country here called Sao Tome. There's a time I wrote maybe a code like YGLM writer. It's there, name GLM writer. You can see it's saving for us everything that you've written. You can also go to even your history. So history, it's telling me the immediate things that I've been writing. So you can see there's country there, there's Sao Tome, and then country I wrote so that it returns to me the component of the variable country. You can look at those connections if any, and then you can look at tutorial if you want to learn something, to install the learn R package. You go to here, you will see various files that I have. These are files inside my laptop. There's Coursera, Google Analytics, there's those bank accounting, opening, Bounty Analytica, academic research. We have all those, and even those are here. The plots that I am writing here, I'll see them in this place. Packages that I have installed, or packages that I need to install. These are packages in R. You can see all of them. So if it has a tick, then it means that they are either installed in my laptop. So I have even like this scheme R, or I can just load them or just install them. You'll see how to install them. You have various packages here: the read Rs, the PAR, we have apply R, we have very many packages in R that you can use. Lubridate also is one that is used to when you're working with date. So you want to maybe modify dates here and there, you'll be using Lubridate. You want to extract maybe only month, you want to extract years, you'll be using that Lubridate. NeatR is also there. We also have even the janitor package for cleaning data. You can see simple tools for examining and cleaning dirty data. Yeah, so we have even the here package where you can find your files. ggplot for creating those visualization elements. You want to create those things that we were doing in Power BI last week. Dplyr, this one for data wrangling. You'll see it there. Yeah, and quite a couple of them. Okay, so here is the console where your codes are being run. This is the environment window. You'll be seeing history and such like stuff. Here you'll be seeing your files. You can even ask for help, right? There is R Studio community that you can ask for help. You can even look at R Studio cheat sheets to help you just getting help with R on Stack Overflow. By the way, if you have any issue, Stack Overflow is really there to help in resolving any problem that you have, because the problem that you have, somebody has also passed through it in the previous past. Victor, have you looked at anything in Stack Overflow? Victor Sangoro?
Yes, yes.
Yeah, who has not engaged with Stack Overflow? Said Suma. Your microphone is on mute. Okay.
Hi,
No.
sir. I don't have that one. The Stack Overflow.
Stack Overflow is just a web portal where you can just ask
Yeah, but
for.
it's not showing here in help.
It's not showing here in R resources.
No, no.
No, even if it's not showing, you can just be using you can just search for anything here. Like just go to Stack Overflow. If you just search Stack Overflow and ask any question here, so using this search, you can search for any question, or you can just ask any question. Maybe I have a problem, but this is really not. Let me just try it out. Problem installing Studio. Yeah, or maybe I'll copy one of the errors that we found there, and then you'll see how it functions. So you can log in or create your account. I don't have account there, but you can ask a question there. There's this ask a question where you can, yeah, they are telling me to log in. So if you sign up and log in, you'll get to ask any question. But even if you paste something, you'll find answers from Stack Overflow. Let me see any error that we have here. You can be copying even that error. Let me see if we get something from. Okay. Yeah, you can get into Stack Overflow, create an account with them, and then you'll be able to get access to helps regarding maybe any point where you get stuck with your coding and things like that. So it's an online, it's a web application, not really an application, but it's a website to help you get answers to your R queries. It's not only R, Python, C++, HTML. It's for basically for data science, all these statistical tools that we have. So you will be getting help there. Okay. Yeah, so another thing that explains to us, again, even numerous packages, we've gone through them here, and you've seen that there are many. There are even other packages that are not here. There's also a package called Arsenal. It's not listed among these ones, but if you try to install it, you'll find it. There's even other packages here. For example, okay, Lubridate is there. Palma Penguins is a package, but it's containing a certain data set called penguins, and that it's also not maybe present here. So there are so many packages that are not shown. For example, you cannot see them there. Yeah, so R has numerous packages. Okay, so the first thing that you want to do is now to set your working directory. What do I mean by a working directory? Working directory is, of course, a location on your computer where R will be using to read and to read and write files, right? It's more of where is it going to even like do the saving of the work that you're doing, right? You understand what I'm saying? So you can define that place, like R is going to store them. Where is it going to store all the files that I'm writing in R? Am I going to store them in my desktop, or maybe in my download section, or maybe in my documents, or yeah, you understand uh, all those corners where you may want your data to be stored, right? So the first way in which you can store your, or maybe set your working directory, first map out the path that you want it to be stored. So for example, you, you can see that for me, maybe what I mapped out is the users. It's the users, HP, documents, Bounty Analytica, R classes, right? Let me just show you that. So maybe what I wanted is I want it to be stored in the documents, Bounty Analytica, and I want it to be stored in the R class, right? So there's this path that I want it to follow, right? That is where I want it to be stored basically. So it's different to maybe yours. So I'll just maybe even double tap here so that I copy this line, I copy this path, I mean, right? Are you able to do that? because you want to set the directory before starting to write the codes. Yes, Alvin.
Okay, I have a question.
Yes.
Um, you see, like in the case of Python, we used to store them in the desktop sana sana local disk C.
Mm.
What if maybe I want the directory to be in local disk D instead of C? Will it still work?
Yeah, it will still work. So, for example, my let me see. I have not partitioned mine. You can see it's 476, 252 or 476. Like I have not partitioned mine. But in a case where you have local disk C here and you have local disk D here, then you just double tap on local disk D, right? And then follow through the path that you want it to be stored in, right? So suppose that this one was local disk D. So you'll just double tap on it and then maybe find, so for example, it's following this path of users, going to HP, and it's going to documents, and I want it to be stored in, it's Bounty Analytica, and we have it in R class, right? So that if you double tap, you'll still find the same line that I wanted it to be stored in. So I wanted it to be stored still here. So users, HP documents, Bounty Analytica, R class, right? Are you okay, Alvin?
Yeah, I'm okay now.
Okay. Zara, have you tried that?
No, sir. I just go through the file and then I click open the file, so it shows.
No, but we want to set a working directory.
Okay, so I will copy and then I will go to the file and then I will copy that.
Yeah, you may want to just specify where you want it to be stored. So
Oh,
that's why I'm saying like you can follow that channel. So if it's local disk C, you want it to be stored anywhere where you want, you follow up to the last folder that you want it to be stored in, right?
mhm.
Yeah. If I stop here and just write C users, then it will be stored here where we are here, right? But if I proceed maybe with HP and also go to, maybe let me not say I want it to be in documents, I want it to be stored in desktop. Desktop, do I want it in biostatistics, or I want it in any folder that can be here? Or I can just tap maybe biostatistics. Do I want it stored in binary data for normal distribution, role of statistics in public health research, like and such like stuff? If I want it to be stored in binary data for, then I'll just copy this. I'll just copy this, right? So that this is what I take to R, right? Okay. So just double clicking here and then copying this. You copy it and then go to R, and then you write the function. So what you write is set set wd. Set wd means like set working directory, and then you press the brackets, right? If you copy it this way, Control V, it and try to run. Okay, running a code in R, you can use this. You can use run the current line or selection, or you can use Control plus Enter. If I click Control plus Enter, you can see there's an error that we have, unexpected symbol in set working directory, right? But I don't want to use this working directory because I had already set a working directory, but for demonstration purposes, right? So if I run this one, it is not going to run because when using the set working directory, R does not use this backslash, right? But it uses the forward slash. Yeah, so Windows use backslash, but R uses the forward slash. So that is one of the difference now. So when you have copied it, you will change this backslash, right? But even before copying it, you have to write first the double quotations and copy and paste. Control V, and then change these ones. So, sorry, change it to forward, from back to forward. You can change this one, you can change this. And so when you're done, you can click on Control Enter, right? Who is having a problem with that? Yes? Pole pole tukienda. Let me get from Kasola. Are you able to do that? I don't want somebody to be left behind.
Yeah, sure.
Sorry? Kasola? Ronnie, have you done that? Have you set your, yeah, Kasola is good. Ronnie? Ronnie, you're on mute. You're done. Amos?
It's okay.
Okay, that's fine. Migwi, there's Muema, and Stella. Zara
Okay.
done. Migwi is okay. Stella is okay. Evita? Vita is okay also. One last person. Victor,
I'm still stuck somewhere.
where are you stuck? And can we come with a cart to lift you out?
It has worked.
Okay, that's fine. Yeah, so I think we can proceed now. So you already have your. Can you click Get Working Directory and see what happens when you click Get Working Directory? Get Working Directory, you can see several. So of course, Get Working Directory here, it will tell you where you are currently, maybe the path you are currently using to store your files. So mine will always be going to R class. So sometimes you find somebody is wondering, where did I store this file and something like that, blah blah blah, right? I had that question just recently from one of the students that I've I've lost my files. I don't know where I saved them and such like stuff. So the easier way for you to know is just to get the working directory that you've been using, and then you follow that path up to where you'll see what you've where you've been saving them. Another thing also is maybe we now go to the basic syntax, but there's also something that I mentioned here, that for you to make comments in R, you use the hash, right? So when you make a comment, that comment is not going to be run, or maybe it's not going to be executed by R. How do you comment in Python? Suma,
Using hash.
use hash. So you this similar thing you are going to, even in SQL also, you use the hash if somebody has engaged with SQL. Yeah. So that it's not going to be executed. That statement is not going to be executed. So let's go to the basic syntax. Can you try running this hello world and tell me what you're getting if you run hello world? Moses Kalia, you're saying your R has no console here. Maybe you can unmute and tell us the issue.
Yes, mine has no that section for console, terminal, and background.
But it has the one we are at, the basic where we are at right now.
Oh, let me just see.
Maybe the issue is this, it has been minimized this way. Is it appearing this way?
Yes.
You can click on this so that you get it. If you want to overlay, you can do that. Or you can go back to this. Or go to this. So are you okay now, Moses?
Well, let me. It doesn't have. It has this part console, but the first part. Sorry, it doesn't have the upper part.
The upper part. Uh-huh.
The one
Let
where
me
we are
see.
writing code. Yes, that one.
It's this way.
Yes.
You can click on either this or you can click on this one. Are you seeing some things here? Are you seeing these things?
Oh, it is okay now.
Yeah,
Okay.
I got it. I got it. Also.
Even Zara, you also had that problem.
No problem. I just print out. Yeah, hello world.
Okay. So what happens if you type "Hello World" this way? Like if you run this comment, or sorry, not comment, but that line 19. Somebody to unmute and tell us what they're seeing.
Error, unexpected symbol in
Unexpected symbol. If you control, it tells you error, unexpected symbol in "Hello World." So when you're writing strings, you have to put them in. You have to use the quotes, right? So for example, if you execute this one now, let me remove maybe this importance first. So if you execute this current one, "Hello World," and control enter, you'll see that it types now, or there is no error that we get. So this one is just telling you more about the importance of quotes when writing strings. When you're writing strings, kindly don't forget the quotes. For you to get this same thing, you can use print "Hello World." You can use print. But can you try, if you write print "Hello World" again, it will tell you unexpected symbol because of lack of the quotes. But if you press this, let me run this number 24, print, it prints the same thing that you had initially. But how about if you write print with the capital P? You start with capital P. This one is different from line 24 and 23 are different because P ya chini is a small letter. The first one is a print with the capital P. If you type that and try to run it, it's going to get you an error still. That could not find function print. So there is no function in R like print with a capital P. The function starts in small letter. So that also tells you that R is case sensitive. What does it mean by case sensitive? These are basics again. What does it mean when you say something is case sensitive? Let me get from who? Haji Bosharo. What does it mean to say something is case sensitive?
Okay, something is case sensitive. It's like I don't understand, but I think it's supposed to be R, but you use the small r. It gives you an error. It strictly follows the rules of the alphabet, like the way it's supposed to be.
Okay. Okay. Somebody to model the answer again. Alvin Kinoti.
The question was, what does it mean to be case sensitive?
Yeah.
Well, from my understanding, I think it means that if you write capital letter, the language will notice, and if you write small letters, the language will also notice.
Yeah. So it really cares about the letters that you use. For example, if I use age capital all of them and I use age small letter, R will be treating those two as completely different, or maybe two distinct things. I mean, right? Yeah. So that is mostly what it means that R is case sensitive. So you've seen that example with the print function. So it includes variable names, it includes function names, it includes anything that you can think of in R, right? It is case sensitive. Okay. If you have engaged with something like SQL, you'll understand that it's really not case sensitive. If you write a function with a name like you write maybe Kenya, you write a table called Kenya, and try to get the same table with even something like you start with K, E, N, Y, and then this one you finish with A, it doesn't care. It will just treat this as the same thing as Kenya. So it is not case sensitive. But for R, it will treat this one as a different thing to this one, and it will also be different to something like something of this sort, maybe Kenya like this. So R is really case sensitive, and those are some of the things that even happens in debugging, that you are really wondering what has happened, and maybe you just missed a certain thing, or maybe in your name you included a period, and in the current one that you're trying to maybe execute, you have not included a period, and you're there for maybe 2-3 hours trying to wonder what the issue is. So print with capital, there's nothing like that in R. Print with small letters. So print hello world, and then you can run it, and then you can see that we have hello world here, right? Okay. Another thing, now we can look at arithmetic operators. So what are arithmetic operators? Examples of arithmetic operators? What are some of the examples of arithmetic operators? Collins. We have Collins. Or let's go to Zahra. Any example of arithmetic operator?
I have no idea.
Zara has no idea on arithmetic operators. And Victor? Oh, Stella, your hand is up.
Addition, we have addition,
Okay.
subtraction, multiplication, division.
Yeah, those are some of the arithmetic operators that we have. Mushiti, and I'm seeing you've typed there. And by the way, Joseph, is it Muchiti or is it Mushiti? I'm reading it as a Kikuyu.
It's Muchiti.
Oh, Muchiti.
Yeah.
Okay. Yeah. I've been calling Mushiti. Okay. So arithmetic operators like addition, we can have them there. You have your addition the same way you do addition in in your books, or maybe in Excel or something like that. Division, and then we have multiplication. So addition, of course, you know the sign of addition, which is just the plus, right? Subtraction, similar to that, just subtract. And division, we have this, right? And multiplication, you have the star on top of 8. So for example, you can see here, I have 5 plus 5. Can you run 5 plus 5 and see what the answer is? Of course, you'll just get 10, right? And also you have, for example, 10 times 2. Similar to how you'll just run it in your 10 times 2 is 20. There's also maybe this number 76 and 64 divide by 567. You see it is 135,190.9. And then there is also a modulo operator. This is just more of customizing even arithmetic operations that we have here. What is a modulo operator? Here also we are getting an answer from somebody. And this somebody has to be Nathan. Nathan, what is a modulo operator? Nathan, what do you mean by a modulo operator? I'm seeing Muchiti Joseph saying it's a division. We are waiting for an answer from Nathan. Or if Nathan is not able to answer, let's give Tom. Eric, tell us what a modulo operator is.
I think it's a remainder when a number is divided.
Yeah, so modulo is it's just a remainder. You are always doing things like 5 divided by 3, it goes 1 times, remainder 2. Maybe 7 divided by 2, it goes 3 times, which is 6, remainder 1, and such like stuff. Basic maths that you are doing in primary. That is if you attended primary and such like stuff. You are getting some remainder. So modulo operator mostly tells you what the remainder is. So for example, if you try to run 10 modulo 5, you see that the answer is 0, right? Because 5 goes into 10 2 times, right? Which is 10. So there's no remaining number. The remaining number is there, but it is 0. If you get something like 100 modulo 3, what is the answer, Stella? 100 modulo 3.
One.
Yeah, that's 1. Evita, your hand is up.
Awesome.
Sorry? You can type if you're having a problem speaking. Okay.
Now the modular operator, we use the double percentage.
Yeah, sure.
Okay.
You just write. Oh, maybe you've not written it. So double percent, the 2% signs. You just add 2, maybe 3, and then you run it. You'll have 100. So 3 goes into 100 33 times, which is 99. and remains 1. There's something that we've missed out here, and it's called raising, right? Raising to the power of something. Maybe 2 raised to power 3. 2 raised to power 3, you'll expect it to be 8, right? 2 times 2 times 2. That is 2 raised to power 3. Or maybe 4 raised to power 16. What would you expect 4 raised to power 16 to be? Maybe something like it should be a large number, right? But you can even try it out here. 4, then the raising to power of something, you'll find it on top of 6, raised to power 6, and you press Control Enter. Sorry, what is this? 4096. Oh, I said power 16. Yeah, so raised to power 6, it's that. Raised to power 16, it's this number, which is 4 billion 294,967,000 exactly. So yeah, so you can even write something like 654 raised to power 3, subtract maybe 524 raised to power 2, and you get the answer as that one, which is 279 million, right? 451,688. So that is the arithmetic operation in R. Is anybody having a question there? We'll take silence as we are okay, right? Let's go to something like variables. We also have variables in R. We have variables in R. Yeah, Eric is asking whether we have square root. Yeah, can somebody answer that and write for us the function to the function to return a square root? Let me choose somebody to Joseph. Do you know how to write square root in R? Okay. Anybody with an idea before I write that? Oh, so Kasola. So Kasola has mentioned. So we have a function in R called square root function. If you start writing SQR, you'll see square root and then tab. Maybe I want square root of 456,000, or maybe 456. Yeah, just something of that sort. Anything, I mean. You're trying to get square root. You'll find that the answer is 213.6984. So there is a square root function there that you can use. I hope you also learned what a function is, and you will see that again even as we move ahead. Then we also have variables. What do we call? What is a variable? What is a variable? For those who know what a variable is. Haji, you haven't spoken today. What is a variable?
Variable, yeah?
Yeah, what is a
I
variable?
think that was Python.
Sorry?
Variable, ila tu like tulisoma kwa Python, maybe.
So maybe somebody did
Is
not
it the same
did not
thing or is
study.
it a different thing?
Yeah, variable is variable. It's the same thing. So can you define that same thing? Haji is a little bit stuck.
Okay, variable is like is used to store an information. Yeah.
Yeah, so it's when we are doing statistics, we used to define it as just any characteristic that you can have there. You can even measuring in terms of even counting or something like that. Variable comes from the word varying, right? Right. So it's just any kind of characteristic that you can think of. Uh, you can think of a number or just something that you can measure. And for example, if you have x, we have x here, and we are defining x as 90, right? So x is a variable. Variable can contain any number. It doesn't mean that x has to be just 90. X can be at one point in time, x can be 20. At another point in time, x can be even 0.00003 or something, right? So x is something that is really not constant as such again. So that also bring in the definition of, or maybe the context of varying, right? So variable is something that again can be measured. You look at, maybe for example, x, we've talked about that, x is 90, and maybe we can talk about how you can define a variable, right? And looking at those examples, maybe let me bring in a different thing. There's a time I had written even maybe name. I've told you how to type that and include the hyphen. This is how we can define variables in R. Apart from this, apart from using this one, like the less than and then hyphen, let me first write it and say this is Haji. So name, my name is Haji Bosharo, right? And I'll say Control Enter. So the variable here is name. It is containing data. Which data? Data is here the Bosharo one, the Haji Bosharo. I mean, you can define it that way. You can also define it as, so if I type name and then press Control Enter, I'm being told it is Haji Bosharo, right? Let me also type name one, or maybe name one, and I want to use a different way and call it, and say maybe, who else are we having in the class that you can use? Evita. Let me say Evita Rose, and then do it this way. Sorry, I am passing Evita Rose into name one. So the variable again here is name number one, right? You can see name one has a variable called Evita Rose. Name has a variable called Haji Bosharo. I can also write it this way. Maybe let me say name two. Name two. And say name two is equaling to what? Who else do we have here? We have, let's try to see if that one is going to run. You can see name two is Bounty Analytica. So there is this way that you can use. There is this way which you can use. But of course, if you are using this one, then it's the opposite of what we have here. So you are taking Evita Rose and then you are passing it inside name one. Here, what you are doing is to first define the variable, and then, so it's not name that you are going to pass inside Haji Bosharo, but this time you can see that it is reverse, right? Haji Bosharo is the one that is being pushed inside name. Here, Evita Rose is being taken inside name one. So this line number 41, it's more of like a mirror of line 39. So if you can remember how a mirror functions really. Then there's also this one. A question might be, which one will you really work with? Of course, you can work with any of them, but which one do you feel comfortable with, or you think is conventionally right? Which one are you going for, Zara? First one, second one, or third one?
First one.
First one. Alvin, Kinoti. Alvin, you're not speaking.
Beg your pardon, beg your pardon.
Yeah. I'm saying, which one would you go with? Like, we've looked at the three different ways of writing a variable or defining a variable. So there's this method 1, there's method number 2, and then there's method number 3.
I think I'll go with the third one.
The third one. Okay. The first one is what most people do use, and I also find it like just okay to use this, the first one. Of course, you can use those other ones, but conventionally, there's something that maybe most people would really use, or most people do use that one. It doesn't mean that these ones are bad, but okay. So using that, we can define these. We have x is equaling to 90, right? Controlling, and then you can see your x is 90. So if you want to see it here, of course, you can just type that x and control enter again, and you can see it's 90. Don't mind about this one and the bracket. This one is just telling us that we have only one line of code. If we could have been having like 3 different results produced, then tungekuwa na 1, 2, 3. We will see it in matrices, right? You'll see that when we will be writing matrices, and you'll understand that. So I've used again here different methods that we talked about. You can run, even find your y is 89, find your f to be 187, and then you can do just some arithmetic operations. X plus y minus f. So it will add x 90 plus 89 and then subtract 187. Okay. When you try to run that, you'll find maybe -8. So 90 plus 89, that is 179. And then, so 179 minus 87, you'll find it to be -8. Then another thing also here is, you can have all these things that we can save this answer, the output that we are going to get here. We save it into as a different variable altogether, right? So if I execute this, control D, or maybe just execute this D1 and then print, I can just type D and control enter, or I can write print D, and I'll still get the same answer, which is -8. So you can have whatever it is that you wrote, and then pass it into a variable, right? So the variable that we have here is D, or we can even call that variable result, right? Result, and then say get for me result, and maybe here I write result. Another thing that you need to understand is that R executes line by line. So for example, if I highlight all these, R will be executing the first line, goes to the second line, and then executes the third line. So control enter, you can see that it has executed results, and then gave me like the result of the result of the result of result, which is -8, and then when you write print result, you have -8. So this print is really not important when writing when trying to get the value of a variable. Print, we will see it that it is important in loops. When we will be doing loops, you will see the necessity of print. So, for example, there's somewhere that something. Okay, we'll have a look at it. You'll see like the necessity of. So, for example, here if I don't write, so I have, for example, this variable called x, and it contains numbers. This is called a vector. So this is a vector variable. X is a vector, contains 2, 5, 3, 9, 8, 11, and 6. Right? So there's that. And then we have count, of course, 0. We are starting to count from 0. So for value that is in x, that is a loop function. I believe you also wrote it there. For value that is in x here, if that value divided by 3, the modulo that you are talking about, it is equaling to 0, count will be count plus 1. I'll again even explain these things later, but I'm just showing you where it's really important to write print count. Let's try to remove this count and see if it's going to work. Yeah, there should be a point where I have it this way. Yeah, but we will see. This is. Have you met these functions, like such kind of functions, anywhere? Alvin, did you meet it anywhere?
The formatted string function, I've ever met it in Python.
Yeah, this is just loops. This is called a for loops. We'll see it in depth. So where it is important to also even like you can write print count, and it will be running. So here it looks at the values that we have, and if the modulo of if like the value that we have in x here divided by 3 is equaling to 0, it should be counting those numbers, right? It should be counting the number of times we have a value here divided by 3, giving us 0, which you see that it is 3. So 3, because of this 3, and then there's 9, and then there's also 6. And those are things that you'll see in depth when we are going to write the codes. Yeah, so we don't have to use even the print results and such like stuff. So either way, it is working. It is working whether I write print result or I just write result. So the two things work. So there's also instance where maybe you may now need to know the rules that exist, the rules that exist while writing codes while writing variable names in R, right? So a variable can have a short name like x and y, just as we have looked at there, x, f, y, or a more descriptive name like age, car name, total volume, right? But of course, you always want to ensure that your name is not confusing too much. That is again something that we talked in Power BI, provided it's describing what your name is, what your variable is. So for example, let me say you want to name something as what? Any ambiguous name? Maybe the
Sanya.
sorry? So maybe you write this as a variable name, the date I started writing codes, and you want to be using that table every now and then, right? And so every now and then you have to be typing the date I started writing codes, the date I started writing codes, right? While you can maybe change it to maybe start date. Can be a shorter one, but really telling about what you're talking about, right? So start date can be a name. So a variable name can have a short name, X and Y, X or Y, I mean, or a more descriptive name, age, car name, total volume, and then a variable name must start with a letter and can be a combination of letters, digits, period. You saw that in maybe name 2, right? You see that it is a combination of letters and numbers, right? Name 2 is an example for that. So it can be a combination of letters, digits, period. For example, even your email. Email, you find that people are including even special characters and such like stuff. It can also have an underscore. Do you have one where we wrote an underscore? Yeah. So, but we don't, but you can just even write another one here for you to see. An underscore. Okay, so for example, here we have my name, which is Bounty. I have my name here, Bounty still. So if I run this and then run my name, you see Bounty appears, right? Another thing is a variable name cannot start with a number or underscore. A variable name cannot start with a number or underscore. So for example, if I start like King Charles, right? Underscore King Charles as maybe the variable name and call it Bounty, right? You can even see R is telling you that there is an unexpected token, right? Unexpected token. You try to write an expected symbol. How about if we say to King Charles? You also find that there is an expected token because name cannot begin with a number. You know, we've checked that somewhere here. If it starts with a period, it cannot be followed by a digit and such like stuff. A variable name cannot start with a number or underscore. Variable names are case sensitive, and that is something we've talked about. We have age. There's also this age, and there's also this age. These are three different variables, right? And here again, we also said that reserved words cannot be used as variables. For example, you can say null in 4 minus, right? Or true. You start with the true and say, I am, maybe I am unbuggable. And then you try to write that. You tell that in true, I am unbuggable. Invalid, do set left hand side to assignment, right? So there's an issue with this. You cannot use the reserved numbers or the reserved functions or reserved words in R to define your variables or use these ifs and such like stuff, right? So you can run all these things and just see the result. Control enter, all of them will be executing. I am unbuggable, info minus. That one will not be happening. Any question? Any question up to that point? drop any question in the chat section. There is no question there. Pashamai, are we together?
Yes, yes.
And Muema? Zara Mod, no question. Muema, are you together? Muema Mwendwa. Victor? Victor Sangoro is okay. Who else is Hubert? Hubert Moracha? Unmute your microphone. Yeah, so that is an introduction again, even on writing things here and there, and we've looked at arithmetic functions, and we've looked at setting your working directory, and blah blah. Maybe now let's look at something like trying to concatenate in R also. So we've defined, we've defined, for example, this kind of variables. We can also define maybe a variable like cohort, and then cohort is it's a variable containing the word, the info minus class, right? If you run that, cohort is starting in capital. So if you run that, you'll see there is cohort should be somewhere here. Cohort, the info minus. But if I run cohort ya Sindogo, object cohort not found. Again, R is case sensitive. If I run cohort, it's telling me that it is the info minus. And then there is part. Part, I mean, these variable names can be anything, right? It can even be, you can even write anything, like maybe together. I mean, these are things that are just there to be written. You can even have it as X, right? You can have it as Y. You can have it as R, right? These are just variables again. If I write part and then I am part of, you can see that we have part should be somewhere here. Part should be here. I am part of. So of course this one arranges it according to descending. Is it descending or ascending? Ascending. We are coming from A going to Z. So we start from, you can see cohort is here, but part which has just been recently executed, it's here. But your history does the opposite, right? Because it is going step by step to where you can even clear all history entries that you have here, right? These are just showing everything that I've been doing there. So I am part of, and then you can control, and then you can concatenate these two using the paste function. You can concatenate the two using the paste function, right? So the paste function, you just type paste, and then the one you want to start, of course, I want part to start, and then I want cohort to end, right? Cohort to end, and you can just control enter, and then you can see here I am part of the info minus class, right? You can see we did not include full stop maybe here. You can include that full stop, but it is going to leave a space, right? You can include the full stop there, and see I am part of the info minus class, and you concatenate that. But if you don't want any space to be between something, So for example, this full stop that you wanted to include, we're going to use a function called paste zero. This paste zero does not leave any space. Let me try to see if we add here paste zero and then add that period that you wanted to add. You'll see that it's different now. I am part of quote. I'm part of the. You can see here it does not leave any space when joining two, because I am part of is from variable part, and then the info minus class is cohort, right? But when joining part and cohort, you see that there is no space that is left here. So the difference between paste zero and paste is that paste function provides a separator operator, whereas paste zero does not provide any separator operator. In normal case, if you use paste, there should have been a space between class and this period, because period is another element we are bringing in. So you can see the difference between paste and the paste that you are working with. So for example, here we are adding something paste part cohort, and then we want to add another element here that, and I like the progress so far, right? And I like the progress so far. Then you can just click control enter, and you can see that I am part of the info minus class and I like the progress so far. If you try using something like paste zero, let's try modifying here and write paste zero, control enter. You can see I am part, and then getting here to of there is no space, right? Of the info minus class, and then there was and I like is also mixed here in class and I like the progress so far. There's that mixing, because paste and paste zero, paste provides a separator operator, whereas paste zero does not. Are we together? Let me see who is with us and who is with them. Ladies, Kasola is okay. Ladies, Zara. Zara. Oh, Zara, yes. Aloch. Evitaros is okay. Stella.
I am okay.
Okay. There is somebody here also. Welcome, Anne Jeru. Anne must have joined like just some minutes ago. Okay. But you'll catch up. We are just drinking milk, and we'll be drinking milk for the better part of this week. And before we go to starting to introduce ourselves to solid food, but it won't be solid food containing bones. It will be steak. Is it steak or steak? Okay. So another thing, yeah, and we will drink together. Yeah, definitely. Another thing that we can talk about, can you try combining by the or adding a number and a text? Somebody to try adding a number and a text. I'm not talking about pasting, but adding. You can also try to combine a number and a text and see what is happening. Or even let's talk. Let me give you an example, and so that you use this paste. Maybe I want you to combine maybe something like Okay, this is, so there's this is, there is that one, there's this is our, and then there's first is also just another statement, or okay, first, okay, first class. Or so maybe let's write something like this. So maybe 1 out of 4 children in Europe suffer from obesity, and I want this one to be to be you can save it as maybe x to be Europe suffer from obesity. I mean, these are just simple things for you to jog your brain with. X can be that, and also one is just one on its own. 4 is also just 4 again, but then there is also out of. So the only thing here that you are having as a variable is x. But again, we have some portions like out of, and then we have so this out of is in quotes again. Out of then one out of, then 4 is on its own, and then we have children in. So you can have children in as again just on its own. Children in. Yeah, so you have these things. Can you try to use the paste and produce a statement that is similar to what we have here? Somebody to do that very fast. Who is ready? Is Amos here? Amos.
Yes, let me just do it.
Okay. Who is done? We have a few minutes left. Let's be very fast. Quick, fast minus slow. Who is going first? Ross? Not Ross, Amos. Kasola.
Okay, can I give a try?
Yeah, you can give it a try.
So the first thing is to write paste, then you open the brackets. Inside
Wait.
you write 1, comma.
Just a minute.
Okay.
I'm going by what you're telling me.
Write paste.
Uh-huh.
Open the brackets.
Yes.
Inside write 1, comma. Then parentheses, no, not parentheses, but out of in quotes. Then comma 4. Comma children in quotes. And then comma X. Yeah.
Anybody having a different answer from this? I've just run X only. I've not run the paste. Who is having a modification? And there's somebody putting up their hand. GLM.
Yes, hi. I just realized that at the end of my output, x is 90. Apparently, earlier I had defined x as 90. So I'm not sure whether there is a way of redoing that.
Yeah, you just run this one.
Okay.
This one here, and then run this again. There is no problem. If you run this, R will treat X as having Europe suffer from obesity.
Okay. Okay, thank you.
Okay. So this one, if you run it, then you have 1 out of 4 children in Europe suffer from obesity. So this is just how you can do it, even using that. I mean, those are not really job breakers. Let us look at data types in R. Can you mention some of the data types that you talked about in Python, or maybe data types that you know? I'm starting with the Kilam to type up in the comment section, or unmute and shout them out. There is going to be a prize. Boolean, string, numeric. Date time, tuples, there's float, there's factor, integer, Hubert Muracha. Let's continue. There are others that you haven't mentioned. Dictionary, character, is list, is okay, array. Okay. Let's get example. Number 1 mentioned Boolean. Stella Mudoni, example of a Boolean kind of data type.
The ones for true and false.
Yeah. True and false. That is true. Next, string. Machiti Joseph, you mentioned string. Give example of string. Ah, Joseph, your microphone is on mute. There is date time. Date time. We even talked about that example in Power BI. We have tuples. We have float. There's factor, integer, character. About list. List can actually be containing data types inside it. So we can have a list of names of people, and names again will be qualifying as a string. So we have strings, for example, that we talked about. So in R, there are several data types that can be used to store and manipulate data, right? We are, and these data types again include, we have numeric. So numeric can be, we have, for example, 5 is numeric, decimal is also a numeric. So this is a data that can be used to store integers and decimals, and of course can be manipulated using arithmetic operations. So for example, x equaling to 5 and y equaling to 3.14 pi, right? If you still remember pi, then why is that? Then we also have character or string, right? And these are just data type that is used to store text value, such as names, addresses, and then character values are enclosed in quotes. And that is something that we've looked at in depth. For example, this is a character. You have to enclose it in quotes. Part of, I am part of. So this one is a character that you have to. So for example, name John Smith, address 123 Main Street, or maybe 123 where Kawangware, Korogocho, and such like places, and Runda and the likes of Kilimani. And then we have logical, right? And this data type is used to store Boolean values that Stella mentioned. So such as true or false. So logical values can be manipulated using logical operations. We have logical operations. It's true. We have so we have a this variable that is storing true is false storing false, and such like stuff. We also have maybe integers. Again, I'm going through them this way because we've encountered them in the previous past. And integer, so this data type is used to store integer values. And integer values can be manipulated using arithmetic operations. So you'll find, for example, 25, and we have quantity 10. So there's a difference here that numeric data types can contain decimals, but integer can't, right? You'll find even some people writing integers as just to specify them. I don't know if you 25L. With this L, I mean, when you see that, R will treat it as uh, as an integer, right? So we also have factor. So this type is used to store categorical data, such as gender. What do you mean by categorical data? Somebody to tell us what categorical data mean. When I say something is categorical. Said Suma.
Maybe for this year, it means the data that's it describes category of something. Maybe for gender, maybe gender it's it accommodates male and female and maybe others.
Yeah. So for example, you can this data type used to store categorical data such as gender, product categories, right? Factors are represented as integers with each integer corresponding to. No, are we talking about? Yeah, with each integer corresponding to a category. I mean, so if you look at maybe that gender example, we have factor. So you have to define it as then factor, and then you have all that concatenate. You're joining all these things, or I mean, it's more of a vector that you have inside it. You have all these kinds of male, female, male, and such like stuff. So this is a category for gender. Maybe right now, to stay on the safer side, you can add the they them, right? We have the they them also there, so that we don't be boxed because of not including them. But I mean, anyway, it should just be two. Those people are anyway. Let me reserve my comments. We also have date and this data type. Anyway, can somebody give an example again of even a factor kind of data?
Race.
Sorry?
Race. Like
Risk.
no, race. African, Igbo, white.
Oh,
Indian.
race. Yeah. Okay. Yeah, race can be categorical. You can belong to a certain group. Another thing, maybe in terms of schools in KU. I don't know if you have schools or you have departments. Maybe Department of Maths and things like that. So such like stuff. So another thing maybe is date, and this data type is used to store dates. Of course, dates can be manipulated using date functions. So we have several date functions that you might also see. So date as date 2023 10th 01. You can have that. When you write something as date, it means like you are converting it into a date, right? If you have the as date, if I have a number, for example 23, and then I say as float, then I am converting that number to a float type. We'll see some examples before we drop off. Then there is also time. This data time is used to store time values, and again it can be manipulated using time functions. So if you look at example, I have a variable called time, and then as POSIX city. What is POSIX city? So city means calendar time. You'll see another one that is written like uh, POSIX LT, which means local time, right? Yeah, so this is like a calendar time, and you'll see also maybe local time. Local time maybe the local time that we are operating, depending on where I am. So, for example, right now I am in Timbuktu, so the local time will be Timbuktu. Maybe somebody else is in what South Africa, like Joseph is in South Africa and Amos is in Egypt. So you'll find that there are different times depending on where you are. Stella, where are you right now? Are you in still in Nigeria?
Yeah, I'm there.
Okay, yeah. And so you'll find that it will be. I hope it is writing in Nigerian time, a little bit behind Kenya, so Kenyan time. So that is local time and then calendar time and such like stuff. There is also complex data, right? And also complex data. I think you met it in even in Python. So it's a data type that is used to store complex data. So For those doing something like statistics or just mathematical courses, you met them in basic maths. Then you're trying to do there's complex numbers and operations using, for example, complex numbers. But then what does I mean? I is the, so I can, sorry?
The square root of -1.
Yeah, so I is being the square root of -1, but maybe in this case we can use it to represent a certain value or something, right? So we can have a complex value. So it's really something that it's difficult to, or maybe it's too huge to write, or just as it says, it is complex. 1 plus 2i. So I can represent something. It can represent a negative number. It can represent a certain imaginary number. So I representing an imaginary number. So another thing, okay, yeah. So these data types can be used to store and manipulate data in R. So, and again, this depends on the nature of data being analyzed. So I gave you this example, maybe time, then you write that, and maybe if you write time, you'll see that it is EAT, because I've used here LT, local time. It is telling me that Timbuktu is EAT, like East African time. So it's specifying for me that. Another thing that I wanted to show is, maybe I had mentioned it here, 25L. So if you write maybe Y is equal to 34L, and then we want to determine the type, the data type of Y, you write type of Y, and then it will tell you that this is an integer. Suppose maybe I write X, and then say maybe day one, right? And run day one, and write type of, one, and control enter it. It's telling me it's a double, right? Let me try to pass it as, I want to have X as integer. I want to force it to be, let's try to see if it will accept, or as factor, and then say X, and then control enter, and then I write type of X. You see now I have forced it to be a character. Sorry, type of X. So factors, all the factors are considered as characters. Let me see, as character, as that character, or factor is a type of character. Let me say as character X, and control 1, and then say type of, okay, type of X. Yeah, character still. So all those factors, they will be considered as character. Let's try to confirm it again with what we have here as an example. We had as factor somewhere. So let's see if it makes sense. Control enter, and then type of, what do you mean type of gender is integer? What is the issue with our line? What could be the issue with our line of code? because it should not be. Let me try it again as factor age. Sorry, not age, gender. So levels, female and male. So we have only two factors, that is two categorical levels, which is female and male. And if you type of gender now, control enter, integer. So why is type of gender now being integer here? Okay, let me go and get my explanation on that, and then we look at it tomorrow. And see. Yeah, so if you want to convert something into a certain kind of data that you want, you'll be either using as integer. If I want time, maybe as integer, I may just use the as integer. And then if I want to confirm, so for example, type of x, where is x? X we had as day one, and then I say is x. Is x a factor? Is x a factor? I'm just trying to ask it whether x is a factor type of data. Then it's telling me no, it's not a factor type by telling me false. But how about if I ask it, is a factor an integer? Is factor an integer? Sorry, is x an integer? Is x an integer? Then it's telling me false again. So it's telling you that x is not an integer kind of data, right? And then you can go all the way and try to see whether even if is it numeric. So I mean, this is how you can confirm it's false, right? It is not a numeric. You can even ask whether is y a date time, is a date type of data, is dot date, right? Is date or so is data frame. We can even ask it whether it is it a data frame. We'll look at data frames also. Data frame is where we'll be combining lists. We can even combine vectors and even combine matrices and find a data frame like this. Let's try to see one here and give an example. We have iris. We have a data set called iris. You can even put you can put sorry, what am I writing? There's an iris dataset that we can, unless I'm forgetting the spelling, but there are datasets like iris or mpg, could not find function view. Oh yeah, so I was writing in small letters. So for example, this is a data frame. Data frame is just all those kinds of data that you are even uploading in Power BI. So those are things we call data frames. And that's what I was telling you, that even you can check if our X, is it a data frame really? And then you're being told that false, right? Let's try to see if you write is data frame iris. Let's see the answer, true. It's telling you that it's true that iris is a data frame kind of data, right? And yeah, I mean, those are how you can play around with these things. And tomorrow we'll look at vectors. and vectors and what? Vectors and matrices. And matrices. I mean matrix. So these are just things to introduce you into R. So we look also at vectors and matrices. Is somebody having a question? We are waiting for a question. Ronnie.
Yes,
Are you okay?
I'm good.
How are you? How is R day one?
Day one is perfect. I think I've been active the whole time. I've grasped everything.